take a look at this problem. Got f of x is equal to x squared minus 2x minus 8. And instructions say to graph it, find the x and y intercepts of each graph. We're going to skip the graph part, we'll come back to that, but we'll find the x and y intercepts first. Now for your x-intercepts, you always find it the same way. You're going to plug 0 in for the other variable. So to find the x-intercepts, we'll plug 0 in for y. So we got 0 is equal to x squared minus 2x minus 8. Now this factors using the PSD method, I think. X minus 4, yes it is, times x plus 2. Now the zero factor property. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 4 equal to 0, and I'll set x plus 2 equal to 0, which gives us x equals 4 and x equals negative 2. So our x-intercepts would be 4, 0, and 0, negative 2. Now our y-intercept. You always plug 0 in for the other variable, so plug 0 in for x. Keep in mind f of x is y, so we're going to have y is equal to 0 squared minus 2 times 0 minus 8. Those zeros all drop away and we get y is equal to negative 8. So our y-intercept will be 0, negative 8. Now they say if it's in general form, convert it to standard. If it's in standard, convert it to general. Well, this is in general form. And our first step is to factor out. Now this only applies in some cases. It won't apply in this problem because we got a 1 here. But we would factor a 1 out of the first two terms. So factor whatever number's in front of your x squared out, that coefficient. And that gives us this right here. Now you don't factor it out of your last term. I'm sure we'll see some where there is a number in front of the x squared and we have to factor it out. Then step 2 is we want to take the number that's in front of our x, which is negative 2. You multiply it times a half and you square it. It's always times a half and it's always squared. Negative 2 times a half is negative 1, and negative 1 squared gives us a positive 1. We then not only want to add that inside the parentheses, but we want to subtract it. So we're going to have a plus 1 and a minus 1. That's going to seem kind of weird, but we'll see reason why. Now we specifically are going to group the first three terms together, and we'll group the last one by itself. Our next step is to factor the first three terms. So this is going to factor as x minus 1 squared, then the minus 1 carries down, minus 8. Now if you're wondering, well, boy, he's some kind of factoring genius. I'm not. There's a trick to it. Whatever number's right here, right before you squared, is always what goes right here, sign included. Okay. Then our next step is to multiply the number that's in front times our first grouping, those first three terms we factored, and times the number at the end. So we're going to have f of x is equal to 1 times x minus 1 squared, and we'll have 1 times negative 1 minus 8. Now once we do that, we'll have 1 times x minus 1 squared. 1 times negative 1 is negative 1 minus 8. And then we have f of x equal to 1 times x minus 1 squared minus 9. And this is our standard form. Now, a nice part about standard form is we can easily identify some items. Whatever number's in front of your parentheses right here is your A, so A is equal to positive 1. Whatever number's inside of your X here, this is your H, and it'll always be opposite sign. So this is a negative 1, so H is a positive 1. And this is our K, so K is equal to negative 9. Okay, well, let's proceed on, see what it's asking for. Let's see, find domain range and list intervals which is increasing, decreasing. We'll ignore that. Identify the vertex. Let's start there. And I'm going to change color back. There we go. If you identified your H and K, your vertex is HK, which would be 1, negative 9. Now there's a second technique you can use to find a vertex. And let me put it over here. It's called the Vertex Formula. Writing it in standard form isn't necessarily that easy. So if you merely are asked to find the vertex, then Vertex Formula may be easier. Now keep in mind our original problem here. Our steps in finding the vertex. Step 1 is to identify A and B. A is whatever number's in front of your x squared, which is the invisible 1, 1. B is whatever number's in front of our x, which is negative 2. Step 2, we want to find negative b over 2a. So we're going to plug these in. So I got negative, and we said b was negative 2. So negative, negative 2 over 2 times a, so 2 times 1. Now negative, negative gives us positive, so that's 2 over 2 or 1. Now this is the x part of our vertex, and you see it'll match the x part here. Step 3, we want to plug that value from step 2 back into our original function and simplify. So again, I'm plugging in x squared minus 2x minus 8. So I'm going to have 1 squared minus 2 times 1 minus 8. 1 squared is 1, minus 2 is negative 1, minus 8 is negative 9. Now this is the y part of our vertex, and you see it matches the negative 9 over here. So that's kind of a check. Now A is positive, which means it opens up. That's going to tell us some different items. Our axis symmetry is x equals h. So h we said was 1, so our axis symmetry will be x equals 1. You could also got it from over here. So it doesn't matter how you find your vertex, it's always the x part of your vertex. Now since our graph opens up, that means we're going to have a min. So our min is going to be equal to k. It's actually both an absolute, let me see, k was negative 9. It's actually both an absolute min and a relative min. Okay, domain. Domain is easy. It's negative infinity to positive infinity always for quadratics. Now our range. Our range depends upon whether it opens up or it opens down. We said our graph opens up, so it's going to positive infinity. So I'm going to take the y part of my vertex, which is negative 9, and it's going to start at negative 9, and it'll go to positive infinity. Now our graph, if we look at this real crude sketch here, is decreasing. And this will be decreasing from negative infinity, and it'll stop decreasing at the x part of our vertex, which is 1. And then we can see our graph is increasing. So it'll be increasing from 1 to positive infinity. Okay, now let's look at our sketch. Vertex. What was our vertex? Vertex is 1, negative 9. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 1, negative 9 right there. Our x-intercepts is 4, 0. 440 and negative 2, 0. Ignore that. That should be negative 2, 0. And then our y-intercept was 0, negative 8, which would be right there. Now our axis symmetry is x equals 1. That means there's an invisible line here at x equals 1, vertical line that is. Okay, now we pretty well have our points already, because from our vertex we have 2 points here. So we know our graph is curved like that. Should be more of a curve there. Now, axis symmetry, since we got the left side, we can flip it over, reflect it, and it'll give us the right side. And we know it passes through that point, so that helps. And that'll be our graph.